Okay, good morning, everyone. I'm filling in for Nathan because he's winging his way to Tasmania even as we speak. Traveling interstate is I know it's a strange concept, but it actually happens. I think you all know my name in the room, but for the benefit of people online, my name is Rick Valenta, director of the BRC and acting director of JKMRC. Welcome to everyone here, and thanks for those of us joining online today. Before we begin, just like to acknowledge the traditional owners and the custodianship of the lands on which we meet. I'd like to pay our respects to their ancestors and descendants who continue cultural and spiritual connections to country, and to recognize their valuable contributions to Australian and global society. So it's really a pleasure to introduce Vlad Jokovic, Senior Research Fellow today. Vlad's been involved in research and development of novel processing equipment for more than 15 years, including applications related to ore sorting, mineral classification, microwave technology. He completed his PhD at UQ before focusing on the development of advanced technologies for the separation upgrade of copper and nickel ores, providing increased energy efficiency. Most recently, Vlad's been working on radically improving the classification performance of semi-inverted hydrocyclones, including spending about an hour trying to explain that concept to me. And it seemed very exciting once I sort of semi-understood it. During his career, Vlad has engaged with numerous mining companies, including BHP, Rio Tinto, Anglo American, and Metz companies, including Weir, Metso Outotec, Gecko, and he was I guess one of our biggest contributors to research with CRC ore. And of course, he's been an important and constructive contributor to a whole range of projects in the production centers, a voice of reason and rigor. So in today's talk, Vlad's going to revisit the mine-to-mill concept, which was established at the JKMRC over 20 years ago with a case study from the Barrick-owned Cortez Mine. The title of his talk is The Influence of Ore Blending on Mill Throughput, the Cortez Case Study. Over to you, Vlad.
Thank you, Rick, for the introduction. Good morning to everyone, and thank you for attending today's Friday seminar. Last week, someone who is supposed to present today had to cancel the presentation, and I was asked to step in. So my apologies in advance if my presentation is not so polished, but I hope you'll find it useful. As Rick mentioned, I'll be talking a little bit about. He mentioned that mine-to-mill concept was developed here at this place over 20 years ago, but legend has it that the original idea was created even in the 80s, and that it has been published in 90s. And I'm sure there are people in the audience and online that can explain better than me how and when this concept was developed. But today, but what I want to say that ore blending can be considered as part of mine-to-mill concept. And today's talk, I'll be talking about impact of ore blending on mill throughput. So at the end, it all starts at the end of 2016 when Barrick and Cortez Mine asked JK to help them to address issues of processing different ore types for their newly discovered ore deposits. And today I'll be talking about, this presentation will cover the work that JK team did in Cortez. So Cortez Mine is a gold mine located 120 kilometers from little town Elko. Sorry. So 120 kilometers southeast of Elko in Nevada, in USA. That area, in that area, there are many mines operating by Barrick and Newmont, and these geologically connected assets were used as a basic for Barrick and Newmont merger. So silver was first discovered here in 19th century, and the mining at Cortez Mine commenced in 1969. And after that, several new open pits were new deposits were found. Pipeline deposits, pipeline pits start operating early 90s, and Cortez Hill open pit or CHOP pit started in early 2000. So in January 2017, when JKMRC team led by Sarma Kanchibotla and Malcolm Powell visited the mine, the plant and the concentrator were mainly processed ores from these two pits, Pipeline and Crossroad. So Pipeline deposit was very close to the plant. So the ore was trucked to the plant, whereas CHOP open pit was connected with conveyor belts more than 10 kilometers long, and the ore was shipped by that. So the plan was this CHOP open pit was about to be closed, so it was close to their mine life, and preparation for operating a new open pit, Crossroads, was underway, and a limited ore characterization on those Crossroads ores suggested that ore is it was much more competent than it would be much more competent than the Pipeline and CHOP, and also it was expected that as we go deeper for the Pipeline pit, the ore will become more competent. So overall, Cortez Mine was expecting a significant drop in throughput. At that time, they were talking about drops by 50%. So we started early 2017, and they were expecting in less than a year a huge drop in throughput. So they were really keen to do something about it. Now it doesn't work.
Oh, you got to click inside. Now do it.
So the main objective of the project was to improve operation efficiency and to reduce the risk to Cortez Mine or from processing those more competent ores from Pipeline and Crossroad pits. In addition to that, at that time, Barrick was implementing a huge digitization program, and we were asked to provide necessary tools and knowledge that could be used in that program. So digitization program involved collecting information from geological information, drill and blast information, all from big hole stockpiling in order to help to run the plant. Okay. So the plant was consist of one 3 megawatt SAG mill, and it has pebble crusher on. So SAG mill discharge was a screen using 12 millimeter aperture screens, and screen undersize was sent to the ball mill circuit, which is consisted of 3.5 megawatt mill close with the cyclone. So as a part of the project, just one step back, so they were processing chop and pipeline ore, which at that time were not very competent, and we were asked to run the surveys and done some estimates what would be the expected drop in throughput. So it was a bit challenging for them to find small pocket of deposit in the pipeline which is competent ore, and they found one, and but the blast, it was very small. So first blast, the idea was to do the two blasts with different energy levels. So standard blast and high intensity blast. So first blast was done in February, and because the second blast was planned to do the bench below that bench, so we had to wait till March to remove for that below bench to become available for the blasting. So there was a lot of challenges to run those ones. So all that material was stockpiled, and all the way in October we were allowed to run the surveys of the plant survey. So the standard work was based on the blast surveys, plant surveys, blast trials, plant surveys, and ore characterization. We calibrated the blasting, crushing, grinding models, and used those calibrated models to estimate what would be the throughput for that for the future more competent ores. And what we've done is, because there was very limited information from that crossroad pit, which hasn't been mined, we've took some half cores from that material, shipped it back here at the JK, and run some ore characterization tests. And we realized that ore is not as competent as they were thinking. So overall, it looks promising. So all the simulations suggest that instead of huge drop of 50%, it will be around 23% drop in throughput. Still significant. So while we were there, JK team identified several opportunities for the plant, and we need to be fair for the plant, because for the Cortez staff, because they were processing chop ore, which was very easy to grind. So it was very easy to grind, and it had a lot of gold. And it was unusual for some mine. They have some daily limitation about how much material they can process daily due to environmental issues. So from their perspective, their plan was, and while processing chop, they will easily reach those daily limitations. So they had to push back with the throughput. So in their eyes, there was no need there's no incentive to do any plant upgrades, because the plant was performing as required. So however, we identify these opportunities which to upgrade some equipment so the plant would be in better shape for those future more competent ores. So what we found is the weightometer that on pebble, which measured the weights on a conveyor belt that feeds the pebble crusher, was not measuring properly. So it was measuring more than 100% weight than originally than real values, and that caused that the operator was misled how much material is there, and because there is a limitation how much material that conveyor belt can carry on, the operator has to run the plant more conservatively. So there was a lost opportunity there, and so the other issue what we found was the ball mill trommel. So while they were running during the operation, they found that trommel was regularly blocked and causing the balls cut with that slurry material to be discharged. Reach discharge chute. So what they've done, they just closed the discharge chute, so nothing can leave. Even the ball scats can't leave the system. So that caused that a lot of ball scats were circulating in the system, in the ball mill and cyclone. So that caused excessive wear of the pumps and the cyclone as well. But that's not a huge issue if everything is running constantly. But they have problem with sag sump level, and every now and then that sump level would shut down the whole plant, and then restarting the pumps with pipe full of ball scats was extremely hard. So sometimes they had to empty all those pipes in order to start them again. And this is just an illustration how much ball scats can be, not just ball scat, but bigger balls can be in those pipes. We also recommend to change the sag screen to reduce aperture on those sag screen from 12 millimeters to 8. The idea was to allow sag mill to do more work than now, which would help the ball mill circuit. And because of all the situation that Cortez was facing, with they've all agreed they change everything, and what I'm keep going. And what they realized soon, they upgrade that. They realized that that those plant upgrades were very beneficial for treating pipeline ore. So the throughput jumped, and they were very pleased. And all of a sudden, pipeline ore was not become low priority for those ones. In addition to that, the plan to stop mining the chop pit has been changed, and they keep. So originally they thought by end of 2017 to close that, but they keep mining it 2018, 2019, because there was still more ore, easy to grind, and of course they were incentivized to do that. So that everything caused for priority of whole project just to go quiet. So we were not asked to come back to site and validate our predictions, because they just the crossroad or what wasn't available, which was fair. And transition from chop pit to that crossroad pit started in the second half of 2019. So there are two major geological formation located in that crossroad pit. Those were Horse Canyon and Windband ore. What was noticed is that Horse Canyon ore was much finer, and Windband coarser. They didn't have any ore characterization results on these ores. So no drop height test, no bond ball test. So they didn't know how competent those ores are. But they noticed that the mill throughput, and not surprisingly, mill throughput when they process these ores is correlated to the feed size. Initially, when they start transitioning to this crossroad ore, they've noticed slightly drop in throughput, around 4%. That's when they were treating Windband ore. But once they in September 2019, when they start processing Horse Canyon, they saw significant drop in throughput, about 20%, and that drop of 20% was very similar what JK team predicted. So now Cortez management is facing with the drop in throughput. All of a sudden they reconsider the mine to mill project, and for some reason they were not keen to do the classical optimization in a mine pit. Blast optimization. They wanted to try the blending strategy. The blending strategy has been suggested at the early stage of the project, but at that time they wanted to do classical mine to mill, blasting optimization. Again, customers, it's always right, and we'll follow what they think that they're the best for their asset, because it's their responsibility. So in January last year, so just before, I mean, there's a lot of news about the virus, COVID thing, but we managed to reach USA, and what we noticed is that both Wind Band and Horse Canyon ores have dropped in throughput, and they have similar throughput, unlike previously when Wind Band when plant had achieved higher throughput while processing Wind Band ore. And also what we notice is that for the Horse Canyon, the recirculating load in ball mill circuit was extremely high. So we proposed two surveys for full surveys for those pure ores, and for snapshot surveys for the blends. So based on our previous work at Cortez, we understand that the SAG mill feeling has a strong influence on the performance of overall circuit. And ideally, the SAG mill filling should be somewhere between 25 and 35%, but in this case, it wasn't the case. So what we noticed is for the higher filling, the SAG draws more power. More power means better grinding in the SAG circuit. As a consequence, the transfer feed size to the ball mill circuit will improve, and that will help ball mill to draw more power, generate more grinding, more efficient grinding, or generate more fines, and as a result, the product size will get finer. So, I mean, yep, the SAG power goes up, ball power goes up, and the grinding P80 goes down. So we understand that the SAG mill filling is strongly influenced by the presence of coarse and competent rocks in a feed. So for the hard ores, those hard rocks get accumulated in the mill, and sometimes we need to push back with the throughput in order to avoid the SAG overloading. Whereas for the very soft ores, there's not those large competent material to build in the mill, so it is hard to maintain the mill load. Therefore, the blending soft and hard ore should increase the SAG feeling, improve the grinding in SAG circuit, help the ball mill circuit, and we should see the increase in throughput. I have to say that there's other ways to increase the mill feeling. I mean, opening the gaps of the crushers, optimizing the blast, changing the SAG speed, percentage solids, and other ways. But I want there's no time, and I don't want to there's no need to talk about those issues, those topics now, and I'll be focusing only on blending during this presentation. So in order to run those surveys with ore blending, Cortez prepared 2 mini stockpiles of pre-blended Horse Canyon wind band material. Those were approximately 50,000 tons of material each. So, and they prepared it by just using the large trucks in different ratios. So we have one stockpile which has 16% of Horse Canyon, and the other was 50%. And from those, well, when you say stockpiles, it's different. I mean, the size depends who are you talking about with. So those mini stockpiles, material from those stockpiles were fed to primary crusher in different truck ratio, and to create 4 different blends. So at the end we have 4 blends ranging and percentage of Horse Canyon in them range from 16% to 75%. Because there were stockpile between primary crusher and the SAG mill. This stockpile was coned out, and conveyor belt was, and that blended material was fed directly into that middle hole, just to minimize the transition time from one blend to the other. So for pure ores, full surveys have been conducted. Here, with the stars, I marked those sampling points, and some of the images, how we collect the samples. There were 2 mill stops with crush stops with mill entry. So we measured mill filling, and we used that to calibrate mill fit tool. Mill fit tool is a tool developed here at the JK, which allows to measure the mill filling in a SAG without requirement to stop the mill. So it measured the mill filling online based on and it includes the information about liner weighs, how much grinding media was added, and based on bearing pressure or measured or weight of the mill, calculates the mill filling tool. So with that we calibrated that mill fit tool. For the 4 blends, we run only we conducted only snapshot survey. Snapshot surveys, during that we collected just the SAG screen undersize, so we know what we are feeding to the ball mill circuit, and the cyclone overflow. We didn't do any crush stop, but we used the calibrated mill fit to measure the to calculate the mill filling. So material from collected sample from SAG feed and pebble crusher, pebble material was collected and characterized. So based on A times B results, wind band material was slightly more competent than Horse Canyon, but it requires it requires less power for the ball milling than the Horse Canyon. So during the survey, we noticed that Horse Canyon was finer. Horse Canyon was finer, and it was all the material that we are feeding the SAG mill was finer in case of Horse Canyon, and it was less competent, and so less mill filling was lower, and SAG draw less power compared to wind band. So despite that we are feeding finer material to SAG because there was less grinding happening in SAG, the transfer feed size to the ball mill, and in this case SAG screen undersize, was coarser for the Horse Canyon. And so we are feeding coarser material to the ball mill, which requires more material more energy to grind, and that everything caused to recycling load to be very high. So these are some results. These are the results of the blend. So as expected, the more competent wind band had higher mill filling compared to pure Horse Canyon, and blending soft and hard ores achieved higher mill filling, and that helped with the grinding. So, as I mentioned, the wind band and Horse Canyon achieved very similar throughput, and for all blends, we got much higher throughput. The highest throughput was achieved with the blends of 33% of Horse Canyon. So for these blends, it's not just the high throughput we achieved. The P80 achieved here was lower as well. So we have higher throughput and lower, and we are grinding finer. And in order to compare what was the most efficient grinding in all these cases, we calculated site-specific energy of producing minus 75%, and it shows that 33% Horse Canyon blend is when the most efficient grinding was achieved. But the Cortez stuff were a bit, it's great results, but these are just one. Can we repeat it in a larger scale? They were all very concerned about this wind band material because this was atypical wind band material, because for this material they were expecting higher throughputs. So what would happen if that material was blended with Horse Canyon? Are we going to get the same benefits or not? So they decided to extend this work and test it for longer time. Just to mention that we couldn't push further throughput because of that limitation on the SAG, on the pebble belt that we reached. So this was the best what we could get. So Cortez decided to test the blending strategy on a larger scale. They needed more room where they could create a bigger stockpiles, and because chop pit wasn't operating, they removed the conveyor belt that connect that pit with the plant and expand they call it floor pad. So the capacity of those stockpiling just was reached, so it can store 1.2 million tons of material. So during the period from January to just after the survey, all the way to June, so 6-month period, they were testing different ore blends, different ore types. That blend, the blending process has to be stopped in time to time because they were in parallel. They were doing the upgrade of those floor pads. But what they noticed, and soon they stopped doing the blending, they noticed the drop in throughput. So these results, so all those results were collected, and the information about blends and the average throughput over 12-hour shifts were analyzed. So out of those 6 months, 42% of time they were conducting blending, and out of those, almost half of the time were blends where they blend Horse Canyon and Windband. So these are results just for the blends of those two ore types. They were doing other blends, but these are just two. So arrow bars, because we collect so much data, we could we could calculate 95% of confidence intervals, and those are the arrow bars represents those intervals. What have been noticed? Yeah, Windband achieved higher throughput than Horse Canyon, but the blends, the highest throughput was achieved with 33% of Horse Canyon, exactly what we observed during our survey. The line represents the throughput that it would be achieved if those two ores were processed separately. So, for example, 33% Horse Canyon and Windband blend were processed. They have the throughput about 620 tons per hour, and this would be like if 33% of time was processing just pure Horse Canyon and the rest just pure Windband. And there was 10% difference in throughput. So, because of course that's huge for them, because it didn't, the investment wasn't large just to implement that blending strategy, and because they haven't run the blending strategy during all 6 months period. That 10% difference in the other blends meant that during those 6 months they added additional 5.4% more throughput, and what that meant is they increased. That meant increase of 14.5% over budgeted production. So there's no need to mention that Cortez staff was extremely satisfied with the outcome. So at the end, I would like to thank Barrick and Cortez for the opportunity of for this work. Barrick metallurgists are mostly young people, and they were really keen to help us with the surveys, and hopefully they learn a lot. Special thanks is for the Cortez labs, because all the material has to be sized on site because of presence of cyanide. And of course, the big thank for JK team, both staff and students. And that would be all. Thank you.
Thanks, Vlad. That was really interesting. So I've said to people online, if you have questions, please type your questions in the chat. We don't have any questions online right now, but we have questions in the audience. We'll start with Kim.
Hey Vlad, really interesting presentation. So you are able to establish this experimentally, but is there a possibility to be able to predict what the optimum performance would be with modelling techniques, and what do we need to do to get to that point?
That's a tough question. The issue is the blending. For example, for the ball mill circuit, we measured kilowatt hour per ton. And if you do the blends, you can do those things are additive. So if you have 20% of one ore using this energy and 80% of that, you can calculate what would be expected required energy for those blends. However, for the SAG mill, because we use drop by test A and B values, it's not it's difficult to do that. So it would require a way of thinking. There are some general rules of mixing hard and soft material, but until you test it currently, until you test it, run it through the mill, I think that that's the best option so far. But definitely there should be a way to characterize those rocks, that material, so you could predict how it would behave during SAG mill. But not that I'm aware of now.
Thanks, Vlad. Great presentation. Question. You showed the information about how blending influenced throughput. You didn't show these numbers in your presentation, but did you have any inkling about how blending also affected your overall metal recovery in the end? And, it would be good to know that the gains in throughput did not come at the expense of recovery losses.
Thanks, Lisa. I didn't include, first of all, I didn't have time. I don't have information of metal recovery. Those are we were just deal with the project of how to grind it more efficiently, and all the material was sent to leaching, and those recoveries were closely guarded by Cortez staff, understandably. So we don't know what is the impact on those blends, but what we noticed is during the visit, they said the targeting grind size was around 150 microns. Horse Canyon, the results are shown, they have 200 microns PAT, and they still were running fine with that in terms of the leaching was performing well. Doing blends, because my understanding is that the similar leaching condition was used for both ores, Bin Ban and Horse Canyon, and by blending, the PAT was around between 150 and 160 microns, so finer than for the Horse Canyon. So I don't have the data, but I believe there wasn't. If there was any decremental effect on leaching, they haven't noticed, and they haven't reported, and they just. I mean, I guess we would see the effect on achieved production budget if that was the case. So very long answer for I don't know. Sorry about that.
So we have a question online, which was, what was your typical specific gravity for the HC and WB ores?
Ooh, I don't know on top of my head. I would have to go back.
Yeah, that sounds like a go look it up question.
Yeah.
And this one, do you have any indication regarding the blending cost? What would be the final change in cost per ton of ore processed, you know, if you take into account the additional blending that's taking place?
So I can just assume, so all the additional cost shouldn't be that great because all the material from those two pits were sent on that big stockpile before feeding it to the primary crusher. So I'm not sure whether they feed the primary crusher using existing front loader and a truck, or they have to use another truck and a front loader. So in terms of material handling, there was not a lot movement, but whether they could achieve blending using the existing equipment, my understanding is that's what they've done during those 6 months trial, but whether they invest in the new equipment, I'm not aware.
There might be more, yeah. I'm going to ask mine in case somebody else asks one, because Tim and Lisa both asked ones that I'd written down. What steps did you take to ensure that the material you were working on was representative of the two sources? In other words, that it's not some sort of outlier that isn't really representative of the bulk of the mineralization.
Yeah, that's a good question. I mean, that's why when we got the survey results and we got 20% increase in throughput, we were a bit cautious because that was higher increase in throughput that we were expected. Of course, nothing wrong to have more throughput than you think you would achieve. But we were right that wind band ore that we used during the survey wasn't representative of all. Although there was a mini stockpile of 50,000 tons of material. But my understanding is that Cortez now is tracking material where it is stored in that stockpile, and based on performance would readjust the strategy. Performance of the milling, they would readjust the blending strategy. So it is hard. trick questions, but those confidence intervals that we've calculated show that there is that increase in throughput was real. It wasn't just because of bad sampling or that. So.
It's Frank Shi here. Just want to make a comment on the presentation. I think you did a very good job and very hard job. And I believe the value from your data that are correct. And one of the value of this data is to use JKMRC to validate how that all hardness AB change will affect the blending that efficiency. Because there's a typical two arguments in that submill AB value change for blending ore. One is based on the weight of different ore component. The other is argued by Steve Monroe. It's based on the volume of that ore. So in terms of the final AB value change for the blend ore, that based on Steve Monroe's method is not simply calculated by the average AB value of that by mass, but instead by volume. So it actually take the sum of the reciprocal AB value of different components, and by that calculation, and then predict the final throughput energy consumption or that work. So I think your data, we can do that because you've already done the AB characterization for individual ore and you have different blend ratio. You run the survey. So I don't know whether you've already done the JKMRC on that scenario. And this could be a good paper on that published maybe in the SAC conference, something like that.
Yeah, we could speak about that, but first we need to check with Cortez. I mean, all these information that I presented have been already in the public domain, and because I have little time to prepare everything, I didn't have time to include more data because it would require approval from Cortez, and just it was I didn't have time for that to wait. So. Definitely, I agree. There's a lot of we collect a lot of data, and yeah, publishing a paper could be we could use for that. But you answered the Kim's question about it is possible. So thanks for that.
So last question.
Thanks, Vlad. Just a quick one from energy and emission perspective. How do you see your work can reduce the amount of energy or emission required, or can say energy intensity, the whole process? Because I believe that you need to spend some sort of energy for making the blend. Then the whole thing will reduce amount of energy intensity. But have you even worked it out in total? How many percentage can you save in energy or emission?
Well, to be honest, I've never done those calculations in this case. So, but as I mentioned, the material comes from in terms of material handling, material would move anyway to that stockpile and get picked and sent to the crusher. So, material would, for those stockpile from those pits will have the same material, will go through the same material handling with or without blending. So in terms of energy savings, in terms of moving material, there shouldn't be a much more energy, additional energy required. But it all depends where those stockpiles on Windband and Horse Canyon are located on that flow pad, and how far from the crusher. So there will be some small changes, but I don't expect it's going to be huge.
All right. Well, thanks very much, Vlad. I think we turned 10 o'clock now, so we might draw it to a close, but thanks for a great presentation. There's no seminar next week because it's school holidays, so we're taking a bit of a break. I know some of you are going on holidays and are allowed to go on holidays. There's no lockdown. So I hope everybody who's taking holidays, I hope you have a great time and a relaxing time. So, and I guess we'll reconvene in a few weeks' time. So thanks again, Vlad.